Well, symplectic geometry is a study of space, structures in space. And the structure, it's a very special structure that arises from physics. And so you're looking at space with an additional structure, which is very important, both in classical and in very modern kinds of physics, like string theory. For me, I just study finite dimensional versions of this. So it happens in 2 dimensions, in 4 dimensions, in 6 dimensions. And actually, a lot of the interest is in 4 and 6 dimensions. You can look at high dimensions, but 2 dimensions is too easy, usually. 4 dimensions is always very challenging, and 6 dimensions is just unknown at the moment. Well, I always loved mathematics. So, from very early on, I was very good at it, and I enjoyed being good at something, and I always found it very beautiful. So, it's the one subject that I feel I have most talent at. So, when I was a teenager and trying to decide what to do, I decided, well, I liked other things, but I didn't think I had anything special to offer there. Well, I just found mathematics compellingly beautiful. My mother is an architect, so there was sort of mathematics on her side of the family. My grandfather, her father, was actually a mathematician, but he then became a lawyer, but he did mathematics at university. And so she was an architect, so she appreciated both visual things and, of course, mathematics, exact drawing. My father was a biologist and thought mathematics was terribly boring and very lifeless and not, he wasn't attracted to it. But for me, I just found it very compelling. And then there was a wonderful teacher in high school. So I think if it hadn't been for her, I would probably have not become a mathematician, because she really understood calculus and she explained it in such a way that, and Euclid's geometry. So the beauty came out. Well, that was rather amazing. I went to Cambridge as a graduate student, having really no idea what I was doing. But in Britain, when you go to graduate school, you don't have a few years like you do in America to decide what you're interested in and learn about things. You just do what you said you do. And I hadn't put any thought into this, so I did what I was told to do. And I studied von Neumann algebras, which are a particular kind of, a certain kind of algebra. But it just happened that my thesis advisor had been to America and he had some interesting problems, and he suggested this problem to me, and I solved it. So that was amazing. I mean, my first result was not quite what became my thesis, but it was part of my thesis. That in fact, the idea came to me while I was on a train. I was just traveling up to Edinburgh to see my family, and I just had this idea. I mean, it's amazing how ideas come in a flash. You just suddenly see something. So I saw this, and this actually was my first real mathematical result that gives you a great sense of confidence if you've actually proven something. Well, I think you're taking that from something I wrote about my time in Russia, because, of course, after I wrote my PhD, I went to Russia because my husband had to go to Russia. Again, I was absolutely not thinking what I should do. I was not thinking of building a career, so I had no idea what I'd do when I got to Russia. I was just going to Russia. And very luckily, they said, who do you want to study with? And I said, Gelfand, because that was the first name that came to mind. And I didn't really know anything much about him, but he is the most brilliant person who told me lots about mathematics and really opened my eyes to the world of mathematics. And I knew incredibly little at that point, because I'd written the thesis, but I was very specialized. So I knew practically nothing. So he thought, but for him, mathematics was the whole world. So he read Pushkin with me in Russian. We listened to music together. We didn't analyze it. The word analysis is not correct. He was trying to explain things to me, explaining the act of creation, saying, these are creative acts, just like mathematics is a creative act. Well, I've always thought of mathematics as an art. You know, I've been saying it's like music. It's like, I also think it's like painting. I think it's very, very creative. Of course, there's an element, you have your brilliant idea, and then you have to write it down. You have to make sure that the proofs are all accurate. There's certainly an element of very, very exact thinking that goes into mathematics. But ultimately, it's very creative, because you see something new. And I think that's like an art. Well, my first encounter with mathematics that I remember, well, actually at school, you know, I went to a very advanced kindergarten where they taught me as much mathematics as I wanted. So I learned to add and you know, all the arithmetic operations, and I really liked it. You know, I loved doing arithmetic. But the first thing I really remember was my grandfather showing me the multiplication tables, and I must have been about 4. And he showed me the multiplication tables up to 10 times 10, I think, and showed me the symmetry, and showed me the patterns that you could see in it. And he found it beautiful. I found it very beautiful. Well, you know, I always enjoyed mathematics, and I enjoyed even the boring pages of addition. I thought, ooh, lovely, I can do all these additions. You know, they all have right answers. I didn't get bored. I know plenty of mathematicians who just hated that, but that was not me. And then, of course, there's geometry, Euclidean geometry, which was a lot of fun, because you could prove very unexpected things just by pure thought. That's what was appealing about that. Well, I would say mathematically, Gelfand in Russia was the greatest influence. And then when I came back from Russia, I worked with Graham Siegel. So he was another very important influence, because I was only in Moscow for 6 months, and I completely changed field. And I came back and was very ignorant. I didn't, you know, I was reading a lot, but I sort of got out of the world of doing creative mathematics. And so Graham Siegel was somebody who brought me back and showed me, we worked together on some problems. And that was very important. And then after that, I would say Gromov, who's a totally brilliant geometer with very, very unexpected ideas. And I've actually, you know, I knew his work from since, you know, the late 60s when I was in Russia. But the reason I'm a symplectic geometer now is that he wrote an amazing paper in the middle of the 80s, which opened the field up. And I sort of latched onto that and started developing those ideas. Well, I think the world has changed for the better as far as women in mathematics is concerned. When I was a young girl, it was thought just totally unfeminine to do mathematics. It was, and those, you can still find people, or probably mostly the older generation, that if somebody is a really distinguished mathematician who's female, she becomes an honorary male, so that the category of a female mathematician just used not to be recognized. Now it's much better. There are many more women who do mathematics. There are women of all kinds who do mathematics. There are women who dress up glamorously and have high heels and enjoy flirting. You know, there's that kind, and then there's a kind, I never did any of that. I thought that was not serious. I was always had to be very serious. So I never wear makeup, I've never worn high heels, I just dress in a very plain kind of way. And you know, I always felt I had to be very serious. So when I was young, I didn't really have any female friends. In fact, I was very prejudiced against women. I've grown less prejudiced against women as I've grown older. I think you know, there are plenty of very good women mathematicians who can be inspirational to young women. Actually, I visited CIRM probably 25 years ago or something. There was a meeting of the European Women in Mathematics, I remember. And I was here and had a wonderful time, but I've basically forgotten it. So I came back. It's an amazing place. I love the nature. I went down to the sea yesterday to have a swim, which was great. I love the forests. And it's, you know, there's a good, very convivial group of people here that you can really talk mathematics to. So it's doing mathematics in ideal circumstances, I would say.